Hello, welcome everybody. I welcome you to this physics class where we are going to discuss how to prepare and pass your physics SSCE for WAEC, West African Examination Council. And I want to wish you good luck, but let's take it on. When you are preparing for your physics exam, I want to start by having a very good foundation in mathematics. The truth is, there is no physics without mathematics. So personally, I like to tell people that physics simply means an advanced mathematics. And that is why if you look at our scheme, in further maths SS1, you see some physics topics like moment of forces, equilibrium of forces, vector resolution. So that's to tell you that in further maths, there is physics. What it means is this: physics is an advanced or further mathematics, even though there are exceptions to the topics and all the rest of them. So if you want to prepare very well for your physics exam, there are major mathematical topics you must know, because I have seen a lot of students who are very poor in mathematics. They want to write physics exam in SSC. I mean, they were there in SS1, they were there in SS2. In SS3, you see them struggling heavily in mathematics. And most times, I am brought to brush this kind of people up. What I do first is to take them through mathematics. Even though I'm not even brought there to teach them maths, one thing I start by teaching them is fraction and decimals. Because without decimal, many questions require you to deal with, in physics, where even when you want to do physics practical, there are decimal places you need to place these numbers. And when you are using them, it must be uniform in their approach. So I need to teach that person fraction and decimal. And many questions in physics, the formulas there need fractional approach. So if you don't know how to solve fraction, you can't even start thinking of how to solve physics equation. Because that fraction, you also take you from fraction to decimal to what we call algebraic fraction. That algebraic fraction is the area where you now learn how to deal with the fraction. Then after decimals and fraction and algebraic fraction, I like to teach this child algebra, change of subject formula, and all the rest of them. Under this algebra, that is, change of subject formula, variation, very important. If I will be able to handle these students and build their confidence in variation and change of subject formula, that is when I can start introducing physics to the person. Because after that, in your journey to writing physics exam and preparing to be a physicist in that level, the next topic you need is unit and dimension analysis. If you come to unit, where we say that we have derived unit and we have basic unit or fundamental unit. In the area of derived unit, you need that same algebra, that same fraction. Oh, one more thing. Indices. Laws of indices is another vital mathematical tool that can only help you in physics. So, we brush that up with that SI unit and dimension analysis. Because the truth is, I quarrel a lot of this. Because of this, I quarrel so much with many of my students. There is no way you will solve a physics question, even a mathematics question, without writing the SI unit at the end. You are given a question in 5, let's say you are given 5 cm as the length or radius in a physics question, and the options given are in meter. You should know how to do a conversion. So that leads us to another mathematical tool you need is conversion. Being able to convert from one unit to another is another vital tool you need to prepare physics. So let me come back to what I have said. Fraction and decimals, I mentioned algebraic processes. I have to include simultaneous and quadratic here. Then change of subject formula. Variation. Indices. laws of indices, logarithms. I need to include these ones. Logarithms, because when you be studying half-life radioactivity, you need that understanding of logarithms, where you use ln in your solution. Then you now need to know how to do a conversion from one unit to the other. These are mathematical tools you need to be very good at before you start reasoning physics. After that, SI unit. SI unit should be like a secretary, is something you must know. Because there's no way you will solve a question. Maybe you are asked to find distance. After finding distance, you write S equal to what? You can't write S just equal to 5 without putting the unit. So unit is very important. SI unit is very important in physics. So then after this, after SI unit, for you to prepare for physics very well, I must introduce motion for you. Speed, distance, and time. You know, this speed, distance, and time is even what you have done in mathematics as well. Like people call it rate and proportion on ratios. You need to brush yourself very well and build confidence. Now, let me tell you one more thing. You need to know the principle of physics. There is something we call principle of physics. You see, people cram formula. You are given a formula. Let's say you are given a formula for height equals to ut plus half at squared. That formula you are seeing there is just a demo. The way you use it for a horizontal motion is not the same way you are going to use it for a vertical motion. So that means you need to come to what is called the principle of physics. Principle of physics is the basic truth or laws guiding any topic you want to study in physics. Let's say, for example, in Archimedes' principle, in upthrust, there is no way you will be able to solve questions in upthrust without knowing the principle of Archimedes. You will always struggle to solve those questions. The principle of physics is studying the laws of physics, understanding how they are used in problem solving. That is what I mean by the principles of physics. For example, in life, in real life, there are principles guiding whatever I do in this real life. For example, there is a principle of gravity. If I leave this pen, it must surely fall down. That is the principle. You can never do anything against the principle. That is why, personally, I like to teach my students how to derive equations. How you derive equation and arrive at the formula you are using. How did it come out? This is what I mean by studying the principle of physics. How every formula will be used. Definitions in physics is very important. I have told people think physics is all about calculation. No, physics is not all about calculation. Go and count the questions that comes out in physics every year. There are theories where you are supposed to be listed. There are ones you are supposed to do calculation. And people will now put all their energy in calculation, forgetting the area of definition, forgetting the use of kinetic theory of gases, kinetic theory of matter. So in studying physics, no definitions, no explanations that back the things you are doing up. These are things I call the principle, knowing the basics. Let me give you, for example, when it comes to motion, laws of motion, there are 3 basic laws of motion. And anytime you are solving questions on physics that has to do with movement, the principle of either first law of Newton's first law of motion or second law of motion is included. When the body is moving with a uniform motion, what does it mean according to Newton's second law of motion? You need to take cognizance of all this. And this is based on the quality and the kind of teacher that is teaching you this physics. So the next one is, I need to bring this topic called vector resolution. Anytime you see a vector inclined at an angle in physics, I advise the best thing you should do is resolve it depending on the question. So you should know why you are resolving vectors. Why do you need to resolve a vector? You resolve a vector in order to have a component of that vector, a component of that force, because vector is a force actually. So when you are resolving a force, you need to resolve it according to the direction of the movement of that body, where the force is acting. And you resolve it either vertically or horizontally, depending on the direction of the force. You should know these skills. Then, you also have to understand the conservation principles. We have conservation of momentum. We have conservation of linear momentum. We also have angular momentum. But I think in your level, in the scope of SSCE, angular momentum is not many. But conservation of momentum, linear momentum, angular momentum, conservation of energy, very important. The truth is that somebody asks you, what is the law of conservation of energy? People say energy can neither be created nor destroyed, but converted from one form to the other. And you forget that this law is the main reason why you solve questions on heat capacity. You say heat loss is equal to heat gain. In electricity and heat, you say a quantity of electricity is equal to the heat transfer. So these are the laws of conservation. Sometimes I don't blame you. I think your textbook is a problem as well. But then you should know laws of conservation of energy and how they apply in heat, how they apply in electricity, even how they apply in Albert Einstein's equation, where when he said E equal to change in mass c squared. Law of conservation of energy. Maybe in that one, maybe we'll talk about quantum physics, but conservation of energy is very important. Even in nuclear physics, the total mass of the body in the reactant must be equal to that in the product side. Because of law of conservation of energy, the energy given in must be equal to the energy given out. That is the reason why all those formulas are there. And that is why we have good interpreters, good physics teachers, who will be able to let you know whenever they do that this principle or this principle is based on the law of conservation of energy. When it comes to momentum, which I have said, conservation of linear momentum, where we talk about momentum before is equal to momentum after. Why? Because momentum does not change. Momentum before must be equal to momentum after, unless you now start talking about in an elastic condition or inelastic condition. These are very important. Then another one is law of conservation of mechanical energy. Law of conservation of mechanical energy is another great tool for solving questions in work, energy, and power, where it will be applied in simple harmonic motion. Yes, law of conservation of energy is applied in simple harmonic motion. In a body falling freely, it's applied as well. So these are the things, the small loophole we see in physics, and you need to take care of. Another one is when it comes to electricity, which is a very important one. We have electricity, which is DC circuit, and we have AC circuit in an SSCE. It's very important you will have a very good command of this topic. When it comes to DC circuit, I personally use Kirchhoff principle, or somebody call it Kirchhoff. Kirchhoff principle, current law, or Kirchhoff current law, or Kirchhoff voltage law, mostly current law, or even the voltage law, they applied in a DC analysis. I used to struggle with electricity questions until I found that law, where I say that the total current flowing into a node is equal to the current flowing out of the node, or algebraic sum of the current at a particular junction is equal to 0. That is Kirchhoff current law. Then I now came to appreciating what a parallel circuit is all about. That is how you prepare your physics. I've mentioned a few other things. You need to be careful with them. Then other ones should be, then when it comes to light, I've talked about heat. When it comes to light, optical physics, optics, you need to be very careful with this principle of, ray diagram. You need to be very good with ray diagram. You also come across Murray's formula and Lenz's formula. Be very careful. I prefer students to use sign convention. Sign convention is very good where you use this one they call real is positive or new Cartesian. You use them both for Murray's formula and for Lenz's formula. It guides you and gives you a good command in physics. So physics is actually very interesting, and also you come across equilibrium of forces where we say that the laws, where we say that moment of forces or even angular momentum. I mean, all these things are very interesting topics. I don't even want to go into all those nuclear physics where you talk about Albert Einstein's equation of this, I mean, energy quantization. Studying physics is very important, and you need to cover all these branches of physics with these few points I've given you. These topics, you need to brush them up. Any other question you have, it is always good you reach out to us. We'll put you through. Thank you for being part of this lesson, and what I do is to wish you very good luck while you are preparing to be a physicist. Have a nice day.